Hello, and welcome to MVP Days for November 2018. My name is Shamir Charania, and today we will explore Azure Blueprints. Blueprints provide the ability to create a fully governed environment that can be deployed in a repetitive manner across many subscriptions. Azure Blueprints is one of the latest tools in the Azure Governance toolset and is still currently in preview. Being a non-regional resource, you can get started today with Azure Blueprints in any Azure region. First, a little about me. I am a Microsoft MVP for Azure and co-founder of a consulting company called Keepsecure. Keepsecure takes a security-first approach to helping companies with cloud computing and DevOps. In addition to a couple of Azure certifications, I have my SABSA Solution Architect Foundations, my GCIH, and I am also a CCSK holder. I blog occasionally at www.shamirc.com, and you can follow me on Twitter. Our agenda here today is going to be short and sweet. First, we will discuss the concept of Azure Management, and then tie that in to the various features of Azure Blueprints. Lastly, I will demo some key features of Azure Blueprints operations in the portal. So what exactly is management in Azure? From the Azure docs, management refers to the tasks and processes required to maintain your business applications and the resources that support them. Let's explore the management cycle. Monitoring is the act of collecting and analyzing data to determine the performance, health, and availability of your business applications. Effective monitoring leads into concepts of site reliability engineering, which eventually allow for proactive management of your applications. Tools such as Azure Monitor and Application Insights fits into this space. In this diagram, configure refers to the deployment and configuration of applications and resources. When thinking about deployment, we want to understand how to not only initially configure our cloud resources, but also understand how to manage and maintain their configuration with patches and updates. In the days of infrastructure as code, automation becomes a key tool in the configure part of the lifecycle. Tools such as Azure Automation and ARM templates fit into this space. In the early days of cloud computing, much focus was put on the automation of configuration to enable faster deployments of required resources. As tooling got better, specialists were no longer called upon to do deployments. Rather, this task was passed along to other resources. There was still a need, however, to ensure that appropriate patterns and practices were being used. Tools such as policy management and cost management make up the govern part of the cycle and allow organizations to ensure resources are deployed according to pre-established standards. Migrate, secure, and protect parts of the cycle all reference the operations of cloud resources. Migrate involves tools such as Azure Site Recovery. Secure and protect involve tools such as Azure Security Center and Azure Backup. Now that we understand the management lifecycle in Azure, let's move on to understanding how Azure Blueprints fits in. From my perspective, Azure Blueprints helps in the configure, govern, and secure parts of the management lifecycle. From a configure perspective, Azure Blueprints incorporates and builds upon ARM templating. One key difference between Blueprints and ARM templates is that Blueprint definitions actually live in the cloud. The Blueprint service offers a built-in engine for automation and orchestration, no longer requiring tools such as Azure DevOps or Azure Automation to automate infrastructure build-outs. From a govern perspective, Azure Blueprints contains all of the artifacts required to describe a target subscription, from policy to resources to role-based access controls. Further to this, Azure Blueprints has the concept of draft and publish versions of blueprint definitions, allowing users to create effective rollout and rollback strategies. Blueprints can be deployed across multiple subscriptions and managed independently through assignments. This allows for managing subscriptions at enterprise scale. Lastly, from a security perspective, Blueprints can help define role-based access controls up front. They can also help ensure appropriate policy is set up by default. And there's a locking feature that prevents changes to defined resources if desired. Luckily, the contents of an Azure blueprint is just a combination of already existing technologies. Resource group artifacts allow you to create the required resource groups, setting the structure for how resources within the target subscription will be grouped. ARM template artifacts allow you to attach ARM templates to appropriate resource groups. Role and policy assignment allow you to configure RBAC controls and ensure appropriate governance is enforced long-term. There are two key requirements for Azure Blueprints besides the knowledge of the artifact types. The first is Azure Management Groups. Blueprints are saved to a management group, and thus you should have already created a management group prior to creating your first Azure Blueprint. Secondly, while Azure Blueprints allow you to configure role-based access controls, it does not allow you to create the Azure Active Directory entities. You should have that already in place. We can navigate to the portal experience for Azure Blueprints by going to portal.azure.com and typing in Blueprints in the top search menu. Here we can see the Getting Started page for Azure Blueprints, where we have quick options to create a blueprint, apply it to a scope, or track assignments. For now, we're going to click on the button for creation. In order to create a blueprint, we need basic information like a blueprint name and a description. The other thing that we need on this page is a definition location, which is a place in the Azure Management Group hierarchy that we would like this blueprint to live. Once we've completed the required information, we can click on Next. On this screen, we are able to now add artifacts to our blueprint. The first artifact we are going to add is a resource group. Click on Add Artifact and go to the Artifact Type Resource Group. Here we can see that there are two values required, the resource group name and the location. We're not going to worry about parameters right now, so we're going to type in Demo Network under the name, and we're going to select the location as West US. These values are now hard-coded in the blueprint. Now that we have our resource group created, we can add artifacts underneath that resource group. The first one we were going to add is a role assignment. The idea here is that when our demo network resource group is created, the network administrators have contributor access to that network by default. Here we select Role Contributor and add user as demo network admins. Click on Add to add that artifact. The next artifact we're going to add is an ARM template. This ARM template is going to define the network resources that we would like deployed under the demo network resource group. We start by adding a display name for the artifact and a description. In the template section, you'll notice that you can either import a template from a file or use the built-in editor to add your ARM template directly. Parameters that are entered into the template are automatically added to the Parameters tab, so you can choose whether to hard-code values in the blueprint or allow them to be replaced at runtime. For sake of convenience right now, we're going to set them all as hard-coded in the blueprint. Once we have everything configured correctly, we can click on Add to add the artifact. The last artifact we're going to add to our resource group is a policy artifact. The idea here is to show you the different types of policies that you can add out of the box to your blueprints. Here we are searching for network using the search bar, but we can also use the type selector to select between built-in and custom policy types. Select a policy that's appropriate and click on Add to add it to your resource group. After we have all the required artifacts added, we can simply click on Save Draft to have our blueprint definition created and saved in the Blueprint Definition section. Now that we've seen how to create Azure Blueprints in the portal, let's dive in to more advanced features of Azure Blueprints. As mentioned before, one of the features of Azure Blueprints is that it has a built-in automation engine. This engine allows for deployment of blueprints at scale to multiple target subscriptions. The lifecycle of a blueprint goes from create edit mode to publish and finally to assignment. In Create Edit mode, Blueprint editors can, using the built-in tools, create definitions of target environments. Blueprints at this stage are in draft mode and cannot be assigned to any target subscriptions. When a blueprint is ready for deployment, editors can publish the blueprint. Publishing creates a version of the blueprint that is then locked from further editing. Published blueprints are allowed to be assigned to target subscriptions. Assignment in this case means the same as deployment. Once assigned, the blueprint definition will automatically be applied. We are now going to go back to the portal and publish our demo blueprint, which is currently in draft form. Clicking on the demo blueprint takes us to the edit screen, where we now have the option to publish the blueprint. Publishing the blueprint is quite easy and requires only two pieces of information. First is a version number, and the second are change notes. Since we are following a DevOps move fast and break things, we're going to release a 0.1 pre-alpha. After clicking the Publish button, we are taken back to the Blueprint's definition page, where we can now see that our demo blueprint has been published. Clicking on that blueprint allows us to now assign the blueprint to a specific scope. Scope in this case can be any target subscriptions underneath the Azure Management Group hierarchy where this blueprint was initially saved. After selecting the appropriate subscriptions, we simply click on the Assign button to process the assignment. The green check mark signifies that our blueprint definition succeeded. Clicking back to Blueprints, we can go to the Assign Blueprints tab and see that our blueprint is currently deploying. Evidence that our blueprint deployed successfully can be found in the Blueprints section of the Azure portal. Further, both the activity log and the deployment section of deployed resource groups also contain various activity. From the activity log, we can see various operations were started by assignment demo blueprint. Note that the version number is not reflected in this log. Here's an example of the Deployments tab of an Azure resource group. Notice the GUID name for the deployment and how none of the information in this panel relates back to the Azure blueprint that was deployed. Here's an example of the information you can see in the activity log for the assignment of a blueprint. Note the search features that allow you to see deployment status across multiple subscriptions at once. In Azure Blueprints, locking is used to ensure that resources defined by the blueprint and deployed to the target subscriptions cannot be altered by processes other than the blueprint deployment. This locking mechanism is different than resource group locks and ensures that even subscription owners cannot alter or edit defined resources. When assigning a blueprint to a target subscription, you have the option of setting the lock feature to none or to all resources. When set to none, no locking is applied to any resources deployed in the target subscriptions. When set to all resources, resources that are defined in the blueprint are set as read-only in the target subscription. Resource groups are set to cannot edit or delete. What this effectively means is that users in the target subscription cannot alter any resources created by the blueprint. They can add resources to defined resource groups and subsequently edit those newly created resources, but they cannot alter the resource group properties. As you can see from the screenshot, locking is a feature that is enabled at assignment time. Technically, blueprints use a feature within Azure role-based access controls called deny assignments. Deny assignments essentially bind a set of deny actions to an Azure Active Directory entity. Because deny assignments can only be created by Azure, removing the locks requires removing the assignment of a blueprint to a target subscription. Resources will not be deleted, but the permissions enforcing the locks will be. Please note that you may have to wait up to 30 minutes for locks to become fully effective on the target subscription. So far, all the demos we have shown use hard-coded variables that are set in the blueprint. In blueprint terms, we are setting static parameters on the blueprint, and these parameters cannot be changed at assignment time. To enable flexible use and reusable design patterns, Azure Blueprints also support dynamic parameters. Dynamic parameters are parameters that can be set at assignment time, allowing for users to change properties on deployed artifacts. There are two scopes of parameters in Azure Blueprints. The first is blueprint level parameters, which are parameters that are globally set within the blueprint. These parameters can be used by artifacts within the blueprint. Currently, you can only set blueprint parameters via the REST API. Artifact level parameters are parameters that are scoped to an individual artifact. These parameters can easily be created in the portal. In this example, I have created two dynamic parameters. The first is a blueprint level parameter, as you can see under the Blueprints parameter section. The second is allowing a user to define the resource group name dynamically at assignment time. Well, that is it for our session today on getting started with Azure Blueprints. In this session, you learned about Azure Management Lifecycle and how Azure Blueprints helps with some of those lifecycle tasks. We discussed the components that make up an Azure Blueprint and the requirements that you would need in place prior to creating your first blueprint. Lastly, we touched on the blueprint features such as parameters and locking. There's much more to know and play around with, especially as the service moves towards general availability. Thank you.